In a moment, I'm going to be speaking to Anton Kapela, which you guys may know from the K03 IMD Channel 3 television station in Eugene, Oregon. That station is the only ATSC 1.0 station, and quite frankly, the only station operating on the public airwaves that is broadcasting 4K TV channels, and it's an ATSC 1.0 station. He's the guy behind that station. But he's not only just a station engineer, he has a very long history in data networks. So, data distribution over some network topology. In fact, he said in one of his IEEE sessions that he did that if it's transported bits, he's worked on it. So, he has a wealth of knowledge and a lot of information about just internet protocol networking and how to move data around across all sorts of channels and what would be the most efficient way to do things. And I'm very happy to say that he's going to be coming on here to talk about how broadcast is more efficient to send data, whether that's a television show, a live TV show, or it's other data. And I created a page on my website called Broadcast and the Environment, which goes into how much more efficient at an electrical level, at a power level, broadcast is for the distribution of a live TV show compared to an internet protocol unicast network with all of this infrastructure in between. Broadcast is so simple that it uses fractional amounts of power, and it is way cheaper, way more power efficient, orders of magnitude more power efficient compared to the conventional internet that we're using. And he's going to share some of his findings that he has calculated in the past, and he's calculated for this discussion. So I'm very happy to have him on and talk about a very, very interesting subject and something that I think is going to be the future of data distribution, at least for content that is being received in mass. In addition, he is going to be talking about some unicast internet protocol stuff that is going to be posted on my second channel, DGR Unicast, and I highly recommend if you're at all interested in some of the technical inner workings of the internet, I would highly suggest that you go subscribe to DGR Unicast. I will leave a link in the description below. And I know I haven't posted much there yet, but trust me, it's going to get interesting soon on that channel, so definitely go check it out. And lastly, I just wanted to say that this WNY discussion, along with all of the other WNY discussions that I've done in the past, are now available wherever you listen to podcasts. So without further ado, let's jump ahead in time. And here's my interview with Anton Kapela. All right, Anton, it is a pleasure to have you on. If you'd like to introduce yourself, I know that when watching your IEEE video that you said that anything that's transported bits you've worked on, if you want to talk about that.
Yes. Well, Dylan, thanks for having me on here. It's been really cool seeing what you've been doing and covering in this space. Excited that someone else besides like my current friends, my circle, is interested in this as well. So, yeah, I started out with telecom being the main thing back. I mean, this is going back to the 90s now. I've been at this a while. So, the thing then was low speed serial lines, circuits on telco networks, and Ethernet was still a new thing for a lot of people. So starting then to now and going through all the stuff in between. So mobility networks, point-to-point radio systems, low, medium, high capacity. To put it in perspective, this is when people still thought of Wi-Fi as the infrared protocol that would bounce off ceilings in offices. This is before it was wireless. So that's a long time ago. Yes, serial lines, radio waves, optical carriers, you name it. If it touches bits or handles them, I probably worked on something with it. So chipset level stuff, software stuff, design and implementation, you name it. So have some patents to my name in the space of the mobility routing, various other things related to low latency work for high-speed trading networks and all kinds of stuff in between. So broadcast and audio video content really is just one sliver of a pretty large pie here.
Yeah, for sure. And that's why, with your background, it is so cool to discuss all of the potential with broadcast for the one-to-many model and its impact for the potential future of mass data delivery.
It's funny you mentioned data casting because in a separate, completely unrelated to my station or anything you've been mentioning kind of thread and capacity, I'm consulting on several proposals into the FCC regarding experimental filings that are addressing explicitly interests in the datacast space. So your timing couldn't be better.
So I know for my page on my website that I wrote, I got into how efficient broadcast is from a power perspective, and I just did some random stations in the two places where I live and work, South Florida, Buffalo, and I chose WTBJ, which is a 1,000 kilowatt ERP full power station. They have like 77 kilowatts of input power. And then a super low power station, only 3 kilowatts UHF ERP with only 0.009 kilowatts of input power, which is insane. That's 9 watts. And the insane thing about that is that their coverage with the 41 dBu contour is 1.1 million people for literally 9 watts. So from that perspective, I know that you've compiled some data kind of similar to mine, or kind of digging deeper into what I was talking about. If you'd like to discuss that.
Yeah, so I started some months ago just related to, the overall interest of how do you think about delivering content to folks in general? And so on the internet, of course, everything is unicasted. What we mean by that is a separate stream or copy of data is sent to every requester, every recipient generally. Uh, IP networks and other kinds of networks, packet switch networks, have options for broadcastable or multicastable sorts of delivery models. But the commodity stuff, when we refer to modern internet service providers today, meaning the Charter, Spectrums of the world, the Comcast, whatever, these are commodity ISPs, and these don't provide services to the user systems like your laptop or your phone or your set-top box that are publicly accessible in a broadcast or multicastable sense, meaning then we're doing a copy per eyeball or copy per playback device, let's say. So that's called the worst case unicast delivery model. So I got to thinking about that. Well, what would it take to do, say, 18 million people in the New York Metro? If you add up everything around Long Island, New York State proper, east chunk of it anyway, southeast chunk of it, northern New Jersey, parts of Connecticut and Pennsylvania that are in the metro market, that's a lot more than just the city itself, which people would say is in the 7 to 8 millions maybe. So all told, in that area, watching, say, a common event like, I don't know, some hockey games, which are super popular, obviously, then you'd have a lot of challenge here in just coming to grips with the raw capacity delivery for doing even a small number of bitrate types of streams per person. So just taking 18.1 million people and multiplying it by 10 megabits gets us, somewhere on the order of 186 terabits. Well, why isn't it just 18 terabits? Where is it extra 6 terabits from? Well, it turns out transport and delivery over commodity providers is not lossless. And as you might imagine, TCP and QUIC and all the things that want to do reliable in-order delivery will retransmit in vain. And so doing a little bit of breakdown modeling where we have, say, a range of consumers that are going to be in a bin of some goodness metric, let's say a power law or a Pareto type distribution, meaning the majority of the viewers are going to have, say, 0.1% loss on average. A smaller sliver would have 1%, smaller yet 5%, and so on, up to, say, 40% loss rates. These are non-trivial amounts of overheads to bake into such a delivery question, right? So we're not just like megabits times users. It's like megabits times users, by all this variable inefficiency baked into whatever the network, call it behaviorisms or qualities or lack of qualities they may encounter. So these are relevant features. That's plus 6 more terabits, which we don't have, is the point I'm making in all of this. Today, commodity edge access networks, even things doing edge QAM insertion for advanced DOCSIS 3 dot whatever and 4 bidirectionally now. This does not get us enough capacity where it matters in the middle to near last miles to support even a 4 or 5 megabit stream times millions of people. It just cannot happen. Physically, it does not exist. So that's the challenge we have in the internet economy today, whatever you want to call that. And if we want to have lower speeds, maybe 1 megabit per person, okay, that changes things. But it's still like 18 terabits. We can get closer to that with a lot of 10 and 100 gig links to head ends and to GPON nodes and so forth. But not everyone has GPON or XGS-PON. Not everybody has DOCSIS 3.1 or better. 4.0 rarely. What's left? The middle of all of that is some, hybrid of building MTU, MDU deployments with maybe some commodity provider supplying a gigabit for the whole building or 10 gig for the whole building, breaking out 10 through gigabit services per unit, let's say, and everything in between. Maybe some DSL is still in there. So we have a whole bunch of platforms that have massive oversubscription baked in just to the fabric of how they are economically deployed. That's at opposition then with what we want to do here. So broadcast is all of a sudden, still relevant when we look at just raw scale and things that are, call it highly targeted, highly popular sorts of events. So sports in particular, any other kind of flash crowd around news, that kind of thing is really an evident example here where if everyone was watching, or even most people were watching or interested in this sort of thing at one time, the whole thing just doesn't work at the rates we want. And it falls down to low speeds, sub-megabit in many cases, and people would just say abort, thinking back to the Netflix attempt at a boxing match, if I recall. In some places it was great, in many places, and it was not great. And whether it was their delivery platform itself or the interconnection lack of capacity between the OCA boxes and their peering locations and edge access networks, it doesn't matter. It still didn't work. So
Yeah.
something's not right. We know that empirically. That's the point to you then, Dylan.
Yeah, for sure. And I think it's just really incredible, to point to that broadcast, in the wireless broadcast sense, it's wireless. So there's no infrastructure build out beyond the stick, that's been there since the 50s, let's say, or, things of that nature. And, the other thing too is, fiber is great. I mean, I think you could, say that, the optimal internet connection would be fiber for everybody. um, you can't walk around on the street, with a fiber cable dangling from your phone. So you have to figure out a way to wirelessly receive data. And the way that we're doing it right now is with cell sites. And there's a lot of inefficiencies with, cell sites. I
Yeah.
don't know if this is something that you want to get into as well.
Well, sure. The challenge with doing this on mobility networks is even more pronounced than in a broadcast capacity, because now we have definite dynamicism and new dynamicisms in terms of link quality that we don't have in a terrestrial network.
Yeah.
Uh, some people in the engineering crowd watching your videos might know and say, well, DSL retrains, it's a adaptive physical layer. Latest generations have retransmission, have ARQ mechanisms to help cover up impulse losses and stuff like that. Great. But the wireless world starts from this. And so all of those things are there all the time. And one of the engineering assumptions in mobility is that of the thousands or tens of thousands of user equipments, the UEs, we call them, that are associated or camping or hanging out on a cell site on one of the sectors of it, are generally not actively sending data most of the time they're there. So we call that, RRC, radio resource control, idle. They are not active, meaning that they're not consuming base station resources to dynamically adapt to the link quality mechanisms that are part of the protocols. So LTE wants to get every last bit it can for every UE, great, but now as a consequence of literally live statistical data that has to exist somewhere in base station memory or near the ASICs doing the radio work to transmit and receive from a thing successfully. That's a limiting factor then in what can be considered active users versus standby or connected users. So many base stations, even at the highest end stuff you can get from latest greatest Ericsson, is only 1,000 active UEs per digital unit per modem. Call it control domain. That might be a physical cell ID mapped to multiple radio carriers as the same cell ID for carrier aggregation or something else. But generally, that's still kind of the same number of slots in the management space of the media access and physical layers of that modem baseband itself. So that's a problem right there. Just full stop. Let's say we had 4 by 20 megahertz CA and a bunch of extension stuff, or 8 by CA and all kinds of gobs of spectrum, and 1,000 UEs were there, and they might all be getting a couple megabits each with the capacity we have now. Then add some, spatial multiplexing, maybe some elementary beamforming. This is a great thing for bits capacity up to that max scale, but that's now 1,000 max. maybe in the baseband ever. So we're stopping. We can't go past that, even if we have capacity. I mean, might even have more capacity coming on with the ultra wideband and everything else on top of this today. So in terms of the, call it care and delivery and call it the effort applied to any delivered stream, at the far end of the complexity and cost scale sits mobility. At the opposite end sits broadcast, to your earlier point. And that's where it's exciting to consider, what is broadcast now in light of the last 30 years of interceding technology. We're getting packets everywhere. IP is a thing. ATSC3, as you know, in most implementations, is using object layer dash stuff, manifest stuff in UDP over a radio channel. So it's already halfway there. There's just no acknowledgement channel. There's no feedback channel yet for most of it. So comparing to mobility is interesting, but to your point, though, it's still a unicast copy delivery in almost all cases. I want to add on one bit here, and that is to say that there is a multicast broadcast layer in LTE and has been since like revision 13 or 12, somewhere in there. And you probably all know about eMBMS, and that's fine and cool, but here are some big, big, big negatives. That essentially IP multicast session, or that stream source that would have been going into a route object or a package on ATSC3 payload, now we're putting that into just literally raw, dedicated resource blocks that are manually, not manually maybe, but generally configured in an explicit manner by the cellular operator to go into subframe regions that are dedicated just to handling this traffic. And then the operator has the same problems and challenges as they do in any kind of ATSC3 space. That is picking a reasonable modulation coding rate to get some reliable delivery to some amount of the user equipment in that coverage area. And then on top of that, we have, the other question of, is this an attachment thing? Is there a paired uplink required? Or is this a, one-way downlink only kind of thing? And what spectrum will we want to use for this? Well, up to the carrier again. So look at what your spectrum holdings are and ask, well, which holding is least valuable to me, such that I would want to dedicate a quarter or a half, or maybe all of the airtime per frame or per subframe area, whatever, to this traffic that now is going to only be this traffic. I can't do other allocations once I've allocated this. This is a challenge now because carriers want to pack everyone possible into as much spectrum as they got or as little as they can use. And anything left over really doesn't exist. There's no leftovers, to be clear, other than areas that are just completely, maybe rural or underpopulated areas or high mobility areas across highways and so forth. But in metros and places that are supporting a combination of normal handsets and fixed access that we see from T-Mobile now, this is a challenging thing to want to insert or change about the network because now you have to give up capacity forever. Here's the punchline to all this, though. The worst part about it is that in every implementation I've seen, this is not a hitless reconfiguration. This is a full reboot of the modem baseband. So I want to enable this thing, map these service flows that correspond to this broadcast multicast distribution tree to a radio resource. That is now a lever I throw, and I can't just pull it back when I want to without rebooting everything, literally. So that's annoying. That's terrible. So what would be a good middle ground? Well, a really complicated baseband feature set that does it dynamically. Nobody wants to touch it. Where does that leave the operator? They don't want to touch it either. Now it's a big risk. Can't roll it back easily. It's a full maintenance window. It's complicated to begin with. It's now a multicast distribution layer to all my distribution nodes for the service flow just for this one thing. No incentives. Other than people paying and broadcasters paying to jump in, and that would need a lot of money to concern them with this. I don't see it crossing that threshold of interest or anywhere yet soon. So yes, it's been there. It's favored. People want to have it. It could be useful. It probably would be useful to enable everywhere to some level. But the question ultimately is, how much spectrum do I give up time-wise, frequency space-wise, resource-wise, for whatever service I get out of it, and who's going to pay to run it? And would it be the same crowd of broadcasters I have today with high power, high tower? Probably. Maybe a new crowd could emerge. Maybe it's regional sports networks. Who knows what it is? These are all tantalizing ideas and opportunities. But then it comes back to this overall question of resources and hardware implementations and support for it. And then last but not least, the UE again is implicated. You probably looked up in our interceding times here, stuff that LG did or various folks did with Verizon in the Northeast, not far from you, years ago. Maybe Samsung actually, if I recall now. And I want to say there was a bit of an activity around getting broadcast multicast stuff to a UE with a player that worked. I don't think it went anywhere beyond a field trial. And so too little, too late, too early. I can't call it. I can't tell what the challenges there really were that didn't precipitate this, becoming a thing. But for whatever reasons, it just hasn't. So I would love to see activity currently, certainly in this space, but I just don't feel as if that's a likely evolution in the near term.
Yeah, so that's a very interesting concept because I saw a post when I posted my page on LinkedIn that I did for that, that environmental study, if you will, for broadcast. I got a very interesting comment back from, a senior member of the broadcast industry saying that, what happens if the cellular industry replicates this and does it themselves, and where are the broadcasters? Where is that monetary incentive? And you've just kind of almost disproven that there really isn't any motivation from the cellular space because of how complicated it is.
Yeah, the motivation is low, complexity is high, and you can imagine in your mind then, what would mediate that, what would change that? Well, partnerships from business around it, right? And so you'd have to somehow have an interesting consortium, partnership, whatever you want to consider it, between content delivery that needs to get out, that wants to get out, that thinks this is going to be cheaper than existing unicast CDN kind of stuff that we have out there. And to the degree and to the frequency that these things want to be delivered and replicated or given to all these receivers, we could argue that the unicast network is just fine as it is, and it's getting better and better all the time, faster and faster. And so things that weren't possible a long time ago, even 20 years ago, like a 6 megabit stream on average to everyone on Netflix, couldn't happen really in 2000, can happen pretty reliably now. It didn't take that long ultimately to evolve the internet that way. And in some people's opinions, Jeff Houston and others in the research community in the internet world, we have created a tier one content feeder network by all the internet activity undergone to date. So, like it or not like it, that's where the internet has been shaped. A delivery thing for bulk data, and we're just taking it on the chin in terms of efficiencies and unicast overheads. Okay, so if that's still continuing, is that rate going to intersect some other new sweet spot sooner or later than the broadcast sweet spot? I think it's probably likely that it already is exceeding and meeting those needs. But at the same time, we have, a ever seemingly never growing need for warnings and uniform delivery of weather events and things that like look at public safety or feel like a public safety interest. And certainly we have a public interest in what was the charge of the management and the duty of the FCC to deal with this resource. And it wasn't initially just auctioning stuff off. It was, fair and balanced. There was a whole bunch of statute stuff that related to content, not just spectrum regulatory kind of stuff. We've gone away from that. We might go back to that. For all we know, people could start getting behind it again. It just takes political will and popular interest. And so, it would be ironic that the reforming and the refarming of this resource comes back from ideas exchanged on essentially two-way media like this on the internet the entire time. How do we
Yeah.
reconsider and use this wonderful uniform broadcast thing in light of the current developments? These are the sorts of synthesis questions that I think about more often than not now.
Oh yeah, and I just think, from just a more general level with the fact that radio is, by definition scarce once it's in the air. I mean, you can do as much as you can with MIMO, with spatial multiplexing to get that radio channel as narrow as possible and
Yep.
serve people efficiently. But it comes to a point where, I find it funny, if we're going, satellite for a second instead of terrestrial, Starlink, what is their major new like thing? It's, oh, more spectrum. It's like, okay, how is that sustainable? If you keep growing to the point where, I mean, there is a point in physics where we can only spatial multiplex so much. There's a point where we can only do so much with RF because RF in the air emitted, by definition, is a form of broadcast. So it is
Yep.
lossy, if you will, for unicast methods when we logically use a broadcasted radio wave for unicast traffic.
Yeah, I would add to your point that in the case of Starlink and low Earth orbit satellite operators alike, all share an approach where various array techniques are used to create reuse opportunities across the physical coverage area.
Oh yeah.
And in looking at their ITU and FCC coordinated allocations, we see an interesting feature where they are allowed one co-channel beam per landfall region or whatever regulatory tiling is used to assess this. And that's a real finite limit now on what you're describing as reuse. So the things that are of course at odds there are array complexity, beamforming fidelity, call it linearity across that formable area, um, selectivity across those edges. That is to say, how rapidly can I engineer the fall off in the field strength across overlapping coverage areas that are from the same array, let's say. And then what's my maximum power limit given the dynamic range of all the parts involved downstream from the modems forward to the actual channel. And all of this together then is a really kind of a pretty limiting set of factors in terms of what power level can be incident, what fuel strength you can expect at the terminal. And as you probably have seen, the way that they want to win here to get more capacity is not through more efficient or better, smarter reuse techniques. It's not through higher transmission power. That's unlikely to.
Yeah.
Uh, Meaning not better SNR, it's just burn more spectrum because we're
Yeah.
not going to get the density any higher per unit hertz, per root hertz. We're going to get more hertz and have, 3 or 4 bits per hertz, maybe max per second on average. That's not amazing engineering to me. That's the cheap, easy way. That's the regulatorily, expedient way. Better would be let's really work on silicon process. Let's get gallium nitride way beyond where we're at today. Let's take whatever the latest tech is and get that voltage gain higher. What kind of power density can we get now if I had 3 or 4 more dB SNR? Maybe better power systems in general, maybe better satellite platforms in general in terms of overall energy efficiency and so forth. Maybe quieter terminals. Gain versus temperature is a major factor
Of course.
in weak signal receive performance here. So a few more K down could mean a threshold of reusability that we don't get today. Maybe tens of K down, and maybe a couple more dB again in the terminal could help us change this a little bit. But that's all considered, I can tell you, hard and annoying, and no one wants to do the hard stuff. That's annoying and maybe costs a little bit more than they want because I need the dollars, right? Not you. So burn spectrum, call it good, and now more bits flow. But again, to your point, it may not help any individual terminal's peak rate. It may help overall density. And that would also look good enough to the operator and given the competitive landscape, it would probably still have commercial success. And so again, that's where things are going because that's just the easiest path forward currently. But again, anyone designing this kind of stuff needs to be aware of the next 3 or 4 or 5 years out. What's the refresh going to look like? And would that reliably substantially change my forecast, my outlook? And I think a lot of the attention, of course, is away from that right now. It's on the absolute next month, now and very small time ahead. And that's fine and all, but the leadership question and the call it the driver for where this could go needs to, I think, be informed more along the lines of given the nature and the physical layer of these things, can we get something back out of it that's another service layer, like a broadcast like service layer? And a Starlink, to your earlier kind of maybe hint, isn't it adequate and is a ripe sort of candidate for that sort of thing. They could have dedicated time frequency resources for broadcast-like applications mapped into the underlying transport structures really readily at this point. But again, who, what, where, why? What's the content going to be? Would MLB get together and do it for all of the teams? Would NFL do the same? Hard to say if there's any appetite or attention for that, given that the unicast thing is kind of working okay, and the patchwork, quilt work of high power, full, call it full power or class A stations are kind of carrying the water pretty well as well. And to your earlier point, even densities from LPs can be substantial. So
Yeah.
I think the fill-in we see from broadcast today and the primary, maybe in some cases on terrestrial two-way, can kind of still evolve together. And I think the question, though, ultimately comes down to how could I even technically combine the two? And maybe what as you're hinting here, a unifying layer of some multicast transport in some sort of RTP thing over UDP could be a way to do that. But again, imagine herding that many cats It's not just like the IETF, it's not just the IESG or some sort of application group or whatever web, equivalent thing standards bodies want to dream up. It's well beyond that when you add the content and maybe some protection for likely some DRM things or whatever else comes into the conversation here. So I see it as a challenging, sticky mess, I guess is how I would summarize that.
Yeah, it's so ironic that in a lot of ways, broadcast is so cheap. It's pennies on the dollar compared to unicast, yet it's so complicated. It's the dichotomy of it's so basic and so cheap, yet so complicated at the same time.
Yes. Well, and so you're familiar with DVB, terrestrial DVB satellite, all these things that came along with or came out of MPEG kind of activity. And so beginning with the transport stream, all the way up to codecs and message layer stuff on top of that, you see examples in DVB from earliest days where file delivery was on everyone's mind. And there were examples back in the day where people did NNTP, so-called network newsfeed or news groups over satellite services on VSAT terminals, on geostationary satellites that had transponder space. And so you can get like a DS3 worth of feed data on this thing, all as a big file delivery protocol over multicast IP. And that worked fine. And then everyone forgot about it in the last 20 or 30 years. And so here we are talking about it again in the age of Dash and HLS and manifest delivery of whatever video blobby stuff. It's not a lot different from what we were doing for network news and things like that not so long ago. And everyone has reinvented the damn wheel, Dylan, in complete ignorance of all the history around here. And I feel as if
Yeah.
I'm not old enough to start saying and complaining about stuff like this, but here we are. I cannot accept this. I'm beside myself, Dylan.
Yeah. Do you think this is actually a very important question? Do you think that unicast will end up being the winner? Like we will eventually just from a physics background, from a energy, from a CPU, from everything involved in all areas. Do you think that's sustainable?
That's a tough one, dude.
Yeah.
I think I think at the speeds we have today, with the things that people think they want to do, and that's a big, big cloudy bubble of kind of assumption guesswork there. With all those things considered, it seems to be the current low energy path. When I say low energy, I mean you throw some fiber in the ground, you do some passive optical network stuff on top, and you let it sit there until it rots. And it might be 30, 40, 50 years before anything is physically, in
Yeah.
jeopardy of functionality. So that's good. That's hard to beat. I mean, the challenge is then, does broadcast really still hit the spot for the convergence of all these things? And so it may. The challenge, of course, as you know, is the receiver side, and
Yeah.
that is just just so much not on anyone's mind as to be absurd. Let me give you an example of why I think it's absurd. TVs have had physically large bezels since LCDs were getting cheap, right? Who's anybody ever built in a decent antenna
I
on a
know. I've thought about that so many times.
It's right
Crazy.
there. It's big.
Yep.
It's big enough for UHF and
Huge.
definitely part of VHF. And then no one's done it. And so what do they even think about this? What do people in general in the market even think about the broadcast medium? I don't think they think closely or nearly to the level you're doing here, Dylan, in terms of what it can do, what can be. I think they're thinking about quarterly bullshit, bottom line, can I
Yep.
sell more things? What's going to sell more things? And that's the fancy dumb remote and the weird spy on you TV VisioWare, whatever brand's doing things lately. And that's turning the crank in the market now. And so no one's paying for the inefficiencies at the hardware device side. No one's paying for inefficiencies at the software and delivery side. That's the consumer's problem. And currently, the consumers have enough money, apparently, to cover all this. So until
Yeah.
something else changes, I don't see it radically altering unless there's like an avert force in technically or regulatorily or what have you to change anything or to modify any of those things.
Yeah, and obviously, Sinclair and, one of the major people from Sinclair, Mark Etkin, he's huge in the broadcast internet, and the Pearl TV consortium, they're trying to rally around this. So kind of to your point, I can see that, Pearl TV, they're trying to get that consortium together to try to bring this to light. How well they're doing that, remains to be seen. I
Yeah.
just want to go back though to your Vizio comment about spyware. I think that's one of the things that I love about wireless one way is that it's anonymous. That is something that we don't have at like I've tried to tell people, even if you use a VPN, even if you use Tor, at some level, you are still not 100% private. Wireless broadcast or multicast is, as long as there's no back channel, you are completely 100% private because there's literally no way to send data back. So,
Yeah, but without getting lost, well, so I don't want to argue against your point.
okay.
Practically
Yep.
speaking, there's really no way to know who's receiving your signal.
Yep.
But if you want to have your viewers and your friends look at some sort of interesting deep sidebars, I would definitely highlight passive radar techniques, and things like that, which are
Hmm.
helping understand the real spatial consequences of free space propagation, if you will. And so one of the examples lately has been people deconstructing environments with passive, essentially backscatter or scattering from Wi-Fi access point sources, just beacon frames, chirping out every 100 milliseconds or so, constructing 3D scenes back of environments from that sort of thing. So at one level, I wonder, is it truly really anonymous? Can I ultimately figure out how many receiving thing objects would be resonant at my channel? Maybe I could kind of intuit that, but there's so much random crap in the environment, probably not. But
Well,
at
I
the
mean, what particular channel or service are you using of the countless,
Exactly.
that adds
So,
to the
so there,
complexity
so
equation.
exactly. So as other than like gross like things near this wavelength resonance, it's hard to
I-
intuit that obviously. But what I'm saying is, don't assume a vendor would sit still on that front. If there
Yeah.
were a cheap legal way to do a U-turn ping response, I bet they would absolutely throw it in
Oh,
there.
yeah.
Anyhow, don't. Hopefully, that's not a good idea for anybody. Don't take anything I'm saying seriously.
Yeah.
Uh, but yeah, the effective point would be to say that a broadcast population should be, decoupled from its sources in the way that they can receive and decode these things. Of course, DRM and checked out keys, time limited cipher systems are all in opposition to that. And so
Yeah.
when you look at what's stacking up, especially with Sinclair and others, the alliances are all about the cash flow and not about what's being done with the media and what's being served or shared. Not the content is secondary. The primary thing is how to lock this in and gatekeep access to that in an economic way. That's it. So I wouldn't argue it's in the public interest. It's in their interest. It's in private interest, and that's good enough right now, given the legal landscape for things to propel forward and get where they're going. But obviously, I don't think anyone in the consumer side thinks this is a good idea.
No, and I think everybody knows my opinion on DRM and such. What is the, motive for sticking with 1.0 when the 3.0 physical layer is just orders of magnitude better? And especially if we're getting into an area with, critical data delivery and we want to make it as modern as possible, that physical layer is extremely important. I'd love to hear what you have to say for that.
Sure. Well, I saw your previous interview with the folks from Agolji, and I believe the CEO had some opinions on decisions made for physical layer stuff way back in the day when different things prevailed in terms of filter performance, adjacent channel leakage, coexistence with analog systems versus digital systems being produced alongside. All very sensible takes. I think your points are pretty fair in terms of what the marketing has shown us from, and maybe some early examples of market trials have shown us from ATSC3 when reasonably reliably configured, not the maximum data rates, maximum coding rates, but the more moderate to maybe a little bit lower than ATSC 1.0 per hertz. And those are all very true things. The data we're getting and the performance we're seeing, especially at low VHF, aren't made up. These are real improvements over ATSC 1.0. But let's look at the practical stuff here. It's going to be UHF. Most of this that's going to remain probably is going to be an ever-shrinking pool of UHF. In those scenarios, we looked at, and Weigel presented this at the NTA meeting last year, the National Translator Association, of which I was also presenting on Ultra HD 4K stuff. And they compared 20 plus sample locations across Chicago Metro doing RMS power controlled A/B testing from the same antenna array, same amplifier, same exciter, just flipping firmware modes between ATSC 3 and 1, and found only 5 or 6% of the locations sampled improved in receive threshold at all. That's configured for roughly the 915's code rate. It was basically giving you about 24, 25 megabits to the physical layer, about 20 usable after all the route and overhead packaging was considered.
Mhm.
And so trying to keep it apples for apples to ATSC 1 bit rate delivery was what the goal was, and appropriate mod code for that and same RMS power. All things being equal, it just didn't move the needle as anyone had expected. And imagine the response in the room here, dude. This was like, where's the miracle? Like, there's supposed to be a miracle here. I was told there's a miracle. Like it's going to make everything better. Well, it actually didn't work out. But again, the caveats are important. This is UHF channel model. This is urban stuff. This is not super bad, deeply multipath stuff. This is kind of like rolly, hilly, plus or minus maybe 7, 8, 10 dB in the channel passband that we care about. And all of those conditions are totally acceptable and reasonable in a current ATSC 1.0 tuner to solve out and to work backwards in terms of channel equalization. And the dynamic range in the receiver post the A to D is now high enough to do all those things without zeroing out anything. So we're not losing coherence. We're not missing demod cases where we were before. We're not gaining a lot of new ones either because the majority of the conditions surveyed in a realistic sense here for UHF just didn't have challenging enough channel conditions. To your point, though, the magic here and the kind of the future going data casting thing could take a different color on when we do layer division multiplexing or subframe allocation kind of stuff, which we just can't do with ATSC 1.0. Everyone knows that.
And MIMO too.
And also, and that's the other thing. ATSC 1.0 was birthed when it was too expensive to even hardly do one transmit receive chain,
Yeah.
on multiple transmit chains. And then the complexity of things like I shouldn't say complexity, just the basic principles of math and things like cyclic delay diversity, transmit diversity from the base station side, from the tower side, just is not even a consideration, right? I mean, you have one high power tower and one big stick to put your thing on, and that's getting me 10, 12, 13 dB, whatever you've gained in my area, and I'm getting my efficiencies met, everything's great. Now I have a second antenna somewhere with a separate signal, differently coded a little bit, delayed a little bit. That's not cool. That's double the cost for what viewership improvement? Well, moderate to maybe low, right? So not considered in the calculus. The receiver side in ATC 1.0 could have had any multitudes of improvements provided by two or more receive paths or chains thereof. Moderate challenges for the antenna sizes below UHF and blah, blah, blah. It's all there. It's all relevant. It's all real factors leading to why we never see it happen here. But we know fundamentally it would improve things. It would have made a tremendous difference for a lot of indoor reception conditions that just weren't resolvable, even with OFDM here. But putting all that aside, looking forward, the only real values I see, and they're not to be undersung, are LDM and time divided, mod cod kind of separations and customizations, if you will, or adaptations for robust concerns or coverage concerns that we're talking about.
Yeah.
And so
And
that
yeah.
alone is a good thing, I think, and that should get someone's attention here.
Yeah, I think for me, the biggest things for 3.0 are obviously fundamentally non-uniform constellations. I mean, when is Wi-Fi going to adopt that? I mean, it's been, ages, and we haven't even gotten a new, modulation scheme since, the stuff we've been using like 15 years ago.
Right.
LDM, like you said, is extremely important when you have multiple services. And then MIMO is, I mean, that's the biggest one because you're doubling your data capacity. And I'm assuming that scenario was, yeah, yeah.
Well, so spatial multiplexing is a cool trick. Um, if your audience wants to do again more sidebar background quests here, I
Mhm.
definitely have them start with Alamudi's code. That's the so-called space-time block code world. And so the idea is that they're trying to not gain capacity with this code. They're trying to gain robustness with this code.
Mhm.
But the robustness comes about from multiple point sources and separate transforms in the environment, of course, for those point sources to a single receiver. Again, it gets better and better with multiple receive chains at the
Oh,
client side.
yeah.
But it took a bit of a leap, though, mentally for folks to get from Alamudi's code to MIMO matrix B. So matrix A is considered Alamudi, B and others and folks in C occupy different mathematical space. I'm not even going to name drop that stuff because it doesn't matter. But the bottom line is matrix B and on is getting computationally challenging to the point where Most folks give up unless there's a real high economic bar or economic point to doing it. And unfortunately, the only economic driver that had enough behind it was mobility, was this stuff. And so today in the broadcast space, even though we could spatially multiplex stuff, and we should, the challenge is in what percentage of locations and what percentage of situations at those locations does the multiplexing actually work? So this is a tough modeling thing. The basic math says that it's still a standard distribution, still a Gaussian process. It's like summing Gaussians on Gaussians. It's going to help mostly where it can. Where it can't, it's still going to fall apart and not decode at all. That's the consequence. So if we spatially multiplex stuff and have two bit streams that I must decode to get anything useful out of either of them, now I've lost a lot. And so to your point, though, if we had a more robustly coded LDM, like say essentially the first 2 or 3 bits of the MSBs of whatever symbols we're doing, and that was STBC, space-time block code, like a matrix A code, then we have some cool things. We have some good properties. Spatial diversity to the receiver helps boost that base layer work. And now maybe we can have a modulation scheme, towards the LSBs that use the multiplexed matrix B code. Here's the thing. Not a single proposal or any tests or anyone out there has been talking about that. It's all been the other crap, which is not going to, we know it's not going to help us. That's the problem I see here currently with where things are at. We know it's just not going to work reliably beyond the normal cases. So why push it there? It's a square, to me, it's a square peg, round hole. The square peg will fit if the hole's big enough, but that's wasteful and terrible. And so around and around and around we go. And I just don't see a good way out of it other than like the LDM with like the spatial diversity stuff, like a single stream kind of thing, and then higher layer of the LDM being one or more additional streams. But then we're back to what is scalable codecs. Who's got them? Who wants to license them for a reasonable amount? And that's a small, short list. Maybe nobody wants to license that for cheap that I can think of. So yeah, challenging. And then let's add the data casting thing back in here. For some delivery, like let's say game updates, OS updates, big bulk stuff where I have to have 1 million copies to 1 million of these things, and I don't want to do it all in unicast. That makes a lot of sense to do a broadcast delivery. The people that want to do it would probably favor a slower trickle background delivery, get it done in 7 or 8 or 10 hours, whatever the delivery can support. We're talking megabits of trickle here, not like tens of megabits. And maybe some fast feedback mechanisms for checking back every couple of hours and reconstructing missed packets or missed chunks or whatever the mechanisms might be. All kinds of great ways to do so-called reliable, so-called pragmatic broadcast multicast delivery in these regimes. The game world has certainly helped innovate a little bit in that space in terms of segments and chunks. Steam has their own format. It's not just one big file anymore, and on and on and on. So we could adapt a lot of those things to the same mechanism here and get some pretty good results reliably, I think. The challenge, though, is, again, that receiver complexity. Is it going to have LDM support? If it's going to go spatial multiplexing, I got to have at least 2 of those chains in my receiver now, 1-to-1, the transmission change that I wanted to code.
So I just want to interject though with that. I think MIMO is much easier deployed on mobile because wouldn't in theory for a set-top box you would need 2 F connectors?
Oh yeah, exactly. That's what I'm getting at here. That's what I'm getting at here. So one of the basic principles in what we call kind of an unstructured, generically speaking, when I spatially multiplex a channel, I don't want that to suppose or to inspire a vision of beamforming or explicit steerage of any sort.
Yeah.
In the classic sense of multiplexing, we're just having 2 transmission point sources or more being received by 2 receiving point samples. Can think of it like a sampler, a pair of samplers, and a pair of emitters. My antennas are just sampling the channel in 2 places in space. And if I have transmissions from 2 different places in space as well, given a scattering environment, big assumption here, it must be scattering, then I can tell apart these 2 separate point sources with my point samplers with appropriate coding to separate symbols orthogonally in the way that the system demands. But if I don't have those 2 points in sample space, then arbitrary numbers of point sources collapse into a confusing mess. So if I had 3 point sources to transmit and 2 samplers, I had the same problem. If I had 4, 10, or 20, I had the same problem. Again, it doesn't get better. unless I'm doing things like spatial diversity for the same related data stream. Then all of a sudden, a single receiver, a single sampler, or two is still useful in the presence of 3 or 4, 10, or whatever senders. But the one-to-one correspondence for so-called spatial multiplexing, this again is the matrix B and matrix C category of these codes in MIMO work. This is the basic tenet. I must have n to equal n, or greater than n to equal n. From the sampler side and so forth.
Yeah.
And so when you look at modern phone designs, modern basebands and radio systems, we'll see four-way receivers everywhere. And in many cases, only two transmission chains exist in the base station for a given band that they might be using. And this is just fine. This helps the receiver tremendously, actually, in almost all cases, whether it's a spatial multiplexing situation or just a spatial diversity situation. And it's not using this to gain capacity. So it's important for your viewers and everyone thinking about this to kind of rationalize where and why and how does the MIMO trickery get me something in my calculus. And for multi-input, single output, it helps a lot for the single output style. If I can do that STBC stuff on top of whatever physical layer I'm managing. But in the case of a mobile UE, now there's actually some real stuff to work with here. And so if we're thinking back to our earlier conversation here about EMBMS and other overlays on NR or LTE physical layers, now we're talking about some real boost, and everyone has it without having to go plug another F connector in. That's a real win in terms of robustness. But that's not where ATSC3 is converging, as you well know. The
Oh,
physical layer is oppositional. The physical layer is completely unrelated to the organization we see in the 1 millisecond framing of LTE, or 10 millisecond overall, but 1 millisecond subframes and bursts underneath all that, and so on and so forth. I mean, this is completely tracking towards like hundreds of milliseconds along burst lengths with 8K or 16K, subcarrier structures. That's not part of LTE calculus at all. The delay spread considerations are not like that. So it's a little bit different. It feels different. The receiver should be way better just by default if we're using an LTE like or an R like chipset. And that should outstrip the utility factor when we look at what it can reach, who it can talk to, compared to the ATSC3 space. And I would feel like that should be alone enough to say, ignore all this stuff. Ignore everything on 1.0 and 3.0. Just forget about it. We're going to focus on encoding things and getting RTP over UDP reliably delivered over whatever the layer is. It could be broadcast, it could be unicast, multicast, whatever. But it's going to be RTP. It's going to be some simple codecs. And if we do things that divide a base layer of video frame and refinement layers and some sort of magic stuff, great. That could be an application specific thing. But yeah, to your point, it's like at some level, we can't assume anything of the classic systems that we've taken in and had evolved from 1.0 to 3.0. And I would add that I don't think 3.0 is a good enough hump to encourage folks to get two-way or three-way receivers. There's not enough there. There's no there to motivate that from what I can see.
yeah. I mean, if we're gonna go that route, just make it mobility all the way. I mean, that's my. I mean, I've been about making broadcasts as modern as possible. That's been
Yep.
basically the point of my channel. Is I don't think the
Yep.
future is people my age sticking in big fat RG6 cables into an F connector that was designed in what the 50s.
Right. It was
I
VHF,
mean,
dude. HF, VHF, that was it.
yeah. I mean, this isn't the future, and if people in these industries, if people in the many media conglomerate broadcast industry think that this is the future, it's not, and they're going to lose a lot of money because
Yeah.
people my age, they're not going to be doing that when they're scrolling TikTok on their phone. And
Well, I was going to say, I mean, the one, the sort of psychology around all this, can also be relevant to bring into the conversation, and that is, there's a certain element of discovery that is exciting for people, and the internet provides this sort of discovery, dopamine hit ongoing, like the scroll, whether it's your doom scroll or your, influencer vanity cringe film
Mhm.
thing, whatever it is,
Mhm.
you're getting constant feedback that what you found is interesting and good. And when I look at broadcast, what do I find that's interesting and good and constantly refreshing or changing across the dial? Almost nothing. I mean, you got to look at things like rabbit ears just to see small shifts in what, HSN or JTV is doing in whatever market. And anyone my age, certainly your age, gives zero Fs about any of that stuff. What would help me? What would be interesting to me? Well, dense news channels maybe would be kind of cool. having something like a playout system that's a carousel of YouTube, top 10 YouTube. That's cool. I mean, stuff that we see like the Loop art people doing, like they got one of
Yeah.
the 4K channels out there I told you about. Like that's like fine art stuff. That's high-end art stuff. And you can just have it scroll by with some cool beats all day. That's way better than YouTube. And no one's ever heard about it, right? I mean, so there's just all this
Yeah.
content that could find an audience. And as you pointed out, like getting that technically interfaced and down the chain is not what broadcast seems to be good at. They could be good at it though. That's my point to you here, or to the audience in general. Is anyone doing program direction could put their thinking hat on, like you and I are, and figuring out what people care about actually, and then putting that on their channel or on a sub channel, and they could use codecs like I use, and on and on and on. And to your point, though, the only kind of chink in the armor here that we see is like Golgi and others doing super dense kind of SD packing. That's a new thing, actually. That's the only new thing, though, in a long time in digital broadcast in Americas.
I give them a lot of credit, but it's also depressing at the same time, that's where it's come to.
It's not that they're obviously they're we can't. I mean, their work is brilliant. Everything they've done in the
Oh, of
codec is
course.
brilliant, and it's not that the content couldn't be more interesting. It's that the thing that makes money is hawking, shiny stuff. And I get it. I totally get it. But that's not the market we are. That's not the 30 million people who aren't in that age range or 40 million people who aren't going to be in that age range for a long time that would never care about these things. And the resources are then squandered in some ways. And so I feel like the discovery question comes back in many different ways. And so when I did some testing here, as a small aside, we had an experimental license in Madison. I think I mentioned about people on Reddit tracking down my test station. If I hadn't done that yet, we
Yeah.
should follow that up and put that in your next series here. But basically, as I was testing slate and color bars and motion stuff, and in various of the programming I was working with at 2160 resolutions, somebody took it upon themselves to notate and to log in an elaborate post on Reddit.
Reddit.
They saw it happen. And to them, that was this kernel of discovery of this new weird thing happening in a medium that had seemed pretty ossified, I would say. Broadcast is fixed and rigid and boring. And here they are seeing different things every day,
Yeah.
right? So just right there, we know that psychology obviously works in so many other ways. We've never brought it until I accidentally did it into broadcast. So, blow it up in some ways, right? Why not have different subchannels every week? Make it a thing that's got some dynamics that actually get that sort of reward cycle, more encouraged. But again, we haven't done that yet, for lack of maybe whatever, but market certainly hasn't pushed us there.
And I think too, a cool concept could be, I mean, if you just flood, your broadcast data capacity with a ton of stuff, high quality stuff, but just a lot. And you had maybe an AI model on device that could, gauge your eye tracking or something like that and provide that feedback. But instead of having to go to the mothership for that feedback, you're doing it locally. And it's that, multicast feed that's, providing the new updated information, but then all of the like unicast-esque features of that for the, tracking and the what works, what doesn't, maybe is done on device. And I think that's an interesting concept too, and obviously would help for data privacy.
Well, so in terms of using spectrum resource efficiently, I mean, the top 1% of things are, the majority of traffic in the live event scenarios that we were mentioning earlier. Sports, number one. In America, I love to brag about this. In America, like the top 100 shows last year were mostly all football games, actual single
Yeah.
games. And the one thing that wasn't a game was a show about football. It was like a draft recap or something like that.
Yeah.
These are like tens of or 30s of or almost hundreds of millions of viewers. Everything else doesn't actually matter in terms of efficiency delivery wise, in terms of these flash events, other than one fabled boxing match we've heard about. Everything else somehow fits. Like every F1 race fits on the CDNs they're using, if you can believe that. But again, that's a million viewer or less problem. We all got that working. And people watch it mostly well after it was live anyhow, so who cares? But when it comes to national interest level stuff, you have a medium that can do a pretty good broad coverage thing here. Let's say it was mobile kind of intersected broadcast delivery. And now there's a fast feedback channel to make up for some stats or to retransmit things or whatever they might be. These can be some good tools. But to your point, though, it has to still fit someone's, market driver, market model. And is that adaptive programming based on interest, on tuning, on activity? Once you receive it, maybe it could be, and it could be really infrequent and really efficiently done that way, without, the trappings of YouTube or Google behind it. It could be any local broadcaster with some feedback on their ATSC3 type payloads, like a web browser type delivery model. And it could be interactive stuff on that level and still have a feedback, path that could work. But again, they'd have to have programming and call it viewership or market, advertising interest aligned in a way that gets this process going.
I guess the only thing that I was thinking of is what you were like looking into with VVC at all for your station, because I mean, I personally think it would be cool if a 1.0 station was having VVC before 3.0. Obviously, the receive side is difficult right now. There's actually a decent amount of devices that have chips, but it's just I don't think turned on with software.
Well, so as you know, the challenge is, what is processed where, and a lot of the systems that do, um, like LG has a, I just moved, by the way, yesterday, so my place is a mess. Yeah, my sitting on the floor right now. This is my new place,
Oh
obviously.
my gosh.
So I haven't even unpacked anything. There's like boxes here, boxes over there. It's
Geez,
just,
and you just joined the WNY discussion regardless. I appreciate it.
but the challenge with VBC and everything else beyond what's, already in the air comes down to the truth table of all of the assigned packetized elementary stream type values. Mara's mentioning something that's relevant here, though, and that is, when they were looking at how to get ABC into a PEZ, or the PEZ units from ABC into a receiver that would decode them, they had to jump over a bunch of hoops and flag stuff that shouldn't have been required, but some devices did require it. And
Hmm.
and the challenge there is now worse beyond, HEVC. As you'll see, if you look in the list, H.265 appears, but 266 does not. So the challenge is ITUT group, technology group, has not gotten the H.266 people together yet,
Mm.
given it a
That's a
flag.
problem.
Well, that's part of it, but it's not necessarily a no. The thing that's interesting is that, the way BBC is supposed to be developed and designed and deployed is as it's an enhancement set to HEVC. Essentially, the same tools are there, the same, raw byte sequence flags are there, all that stuff that describes the start of a abstraction unit, an access unit. It's all the same between VVC and HEVC. And someone could be clever in the decoder and say, oh, I'll just be like greedy, and things that match this AU type, whatever, could also decode mostly with HEVC. And then some things could fail and not display, and that could later be added to decode by a VVC decoder. We could certainly look at putting, VVC or anything really over a TS. The challenge, though, is getting the decoder to figure it out. And if it's in a private stream or other sorts of, program-specific information, then that's the problem, or the challenge. But something like an HD home run doesn't much care. That just sees PIDs, and as long as, the firmware is like cool, bring it through. Great. Tune the whole channel even. Don't filter any PIDs, and all of a sudden you got everything. And so plenty of applications could adopt that informally. We mentioned, I think we chatted before, about AV1 over TS. That's
Yeah.
got some moderate, it had some moderate traction in the spec space. The video LAN, development community was actually behind most of that. It seems like it's kind of stalled. I haven't seen anybody doing it. It certainly doesn't say you can't do it anywhere. But again, a decoder has to exist. Stream identification needs to work in some way. And it certainly could ride along with a private PID right now on a regular, dumb, MPEG transport stream. But again, like have a hacker doing it, have a USB
Hmm.
tuner or a network attached tuner that can do the entire payload, and on and on and on, and then pick out stuff as you can, support it in your player. But in terms of standardization track and ITU, technology group or R or anything that describes, MPEG H things, in TS that hasn't gotten there yet, interestingly.
Yeah, and the cool thing about AV1 is that there'd be a lot more obviously device support that, versus VVC right now, which is very little. And
Yeah.
AV1 would have efficiency gains over compression over HEVC.
Well, so let's
Um,
talk about that for a little bit. A lot of folks in the space and people that work with codecs who are close to them will often have a different view, a dramatically different view of what an encoder is
yeah,
relative to their relationship to it, and it is about the relationship. When we talk and when I presented about the station before, my view on HEVC and how it works is really just a small little bit of paint by numbers syntax that makes a screen show a thing that I think someone's going to interpret as a scene, as a real object, or as a real picture or
yeah,
video. And so I talk about at length, all the shortcuts and all the inaccuracies that are tolerated by most human perception, certainly in the acoustic space, but definitely in the visual. And we look at what works well and what gets, decent looking 24p down to 4.5 megabits for crying out loud or less. And we look at those tricks and we can say, well, all the tools that I need are in HEVC, and actually most of them are in AVC. They just didn't scale to large enough transform units or coding units, but I digress. We've enhanced and increased some of those things in HEVC and added a couple really useful features that just didn't exist in the discrete cosine transform layer in AVC and MPEG-2 prior. But the things that are added to VVC really haven't revolutionized stuff to my view of what would be revolutionary, unfortunately. And they've added things that can now consume complexity that I couldn't necessarily consume or wouldn't consume on the normal cases in HEVC or ABC. And so is it going to be a real winner? It should be. It should be now. It should have actually been the thing we did instead of HEVC. There's so many other reasons for that I won't get into here, but it isn't. And so if someone bought an Ultra HD TV from the day they were released till today, they don't get reliable VVC decoding at all.
no,
They, they get HEVC, up to level 5.0, usually for 30 FPS at 2160 and 60 FPS at 1080. And that's it. But that's a pretty good berth in my mind, in my opinion, if we're going to target something that's viewer centric and viewer kind of a positive here. To me, it's like 60 FPS, high dynamic range, 1080 stuff. And it can look really freaking good if well encoded in HEVC for all kinds of technical reasons that, again, aren't really pertinent right now. But if your encoder can flex those things, I'm talking like adaptive sample offset, I'm talking direct prediction modes that can really use a 10-bit space reliably well. We don't see banding as much now. We see a lot less posterization. Now, high motion scenes, deeply encoded things can do amazing work at 3 or 4 megabits of feed at 60p for crying out loud. We couldn't come close to that with ABC and have it look like anything without a kilowatt worth of coding thrown into it. And back to practical stuff. Igolji is doing 10, 20, 30 joint encoding channels on something way under a kilowatt. For my station, and I didn't mention it before, but it's worth bringing up here. It's fine to throw tens of kilowatts at one encoding session for one cinema demo. It's fine to throw, because that's what's done once, right? We're playing it
mhm.
back all the time. It's fine to do a couple hundred watts per channel in HEVC for 4K live encoding with a lot of GPU acceleration and a lot of high-end CPUs. But that's not the density that the majority of these folks are trying to go for. I'm going for picture quality above all, cost and power be damned because they're so small in the scale of one station. For things,
That's actually just to interject, that's actually a really good segue back to the original topic, which is the fact that broadcast is more efficient in that regard. If you only have to do your multiple kilowatt power once, imagine having
right,
to do that a million times. I
right,
mean, you would
and,
shut down the whole power plant.
right. The thing that might be an impactful thing for folks to think about is that when we're looking at the encoding throughput, even the latest, greatest stuff that I was using and we're using now, to get things squeezed out down to like 4.5, 5 meg and still look like anything takes like, 70 watt seconds per frame. So that means 3 FPS on like a pair of dual Xeon E5, whatever I think it was a version 4 I had, whatever the latest, greatest, fastest chip was. And it's not because the codec is bad. It's not because the codec's hard or complicated. It's that much of the work cannot be parallelized. There is just some minimum serialization things for motion detection, motion ranking, and in terms of rate distortion calculations that you cannot do in parallel, other than, or rather, you can't do them in parallel and get good optimal results. You can get adequate results, but like by adequate, it's like several dB worse than the optimal result. Okay, so people take all kinds of shortcuts and they do sliced encoding. They'll break up the frame into multiple strips. But now we lose efficiency because I can't encode things and predict across those boundaries. That's just a feature that doesn't exist in the decoder.
Yeah.
So on and on. Yeah, I can maybe break up a big job over a bunch of threads over several systems and do it real time. But now I have more power. So it's the same kind of power time trade-off we're talking about no matter what. And whether it's a 3 frame per second average encode rate on several hundred watt system that comes out to like 70 watt seconds a frame, or I'm doing it real time with like a couple 100 watt GPU doing massively accelerated, math work that you couldn't do in the CPU. It still is the same amount of iterations per pixel on average that I have to visit and check and do these calculations to shrink things down and code them adequately. And so if I'm expressing that over one stream, then that's great because now it's going to work everywhere. Every display can do it. And as I mentioned in the deck, doing things that are targeting online delivery with available bitrate ladders and everything else, this is not in line with what we're talking about. So VVC and everything else future looking here certainly could enjoy and benefit by all this existing parallelism work. But again, that's not the focus in most of those cases. They're not looking at doing it live really fast. Up until NVIDIA could accelerate it, the encoder performance was nowhere close to real time, unless for being used for very low resolutions, like below 1080 on modern
Yeah.
systems.
I'm just curious if you were to, because all these codecs build up on top of each other. I mean, from a pattern level, and then also from like in many ways, not
Yeah,
all, but
yeah.
so if you were to take some of the same, let's say things in the toolbox that you could do with HEVC and apply them to VVC, you were kind of alluding to the fact that VVC isn't like exactly what you would have like wanted to have for a codec. I'm just curious if you were to do like the equivalent with VVC, could you achieve compared to the most extreme example with HEVC? Could you supply like pretty much a 50% savings in subjective quality by going full in on VVC, or do you not have enough experience yet, or is
Well,
there too much overlap between the two where that efficiency gain doesn't?
yeah. Well, that's a great question.
Yeah.
So VVC is doing things that on the label, if you were to look at like a like a FDA, nutrition comparison here, you'll see things that are bad fits in HEVC in terms of like multi-view, for example, like
Mhm.
stereoscopic kind of stuff, 180 stuff, things that want to have more decoder rendering offload. And for example, basic things that showed up in AVC, like picture rotation, didn't exist in MPEG-2. But
Yeah.
there, shit you not, there is like a side, stream AU or SEI message you can stuff in there for each slice layer that tells the display how to rotate the thing. Why do you want that? Well, because this stuff has MPEG-4 AVC video and you rotate it when you're using a video call sometimes. Obviously, it should be part of the whole spec, part of the whole codec, right? And on and on and on. So you'll see a lot of that for wide angle, 180 beyond, 360 immersive stuff. That is a lot of detail that the codec now is taking on, not the presentation layer. So for the broadcast purpose, kind of orthogonal, kind of a waste
Mhm.
of attention and value there. And then continuing looking through, in terms of raw algorithmic stuff to express greater squeeze, greater efficiencies. If you were to do things that try to get, call it the 40%, 50% rate reduction versus HEVC, the complexity is not just a little higher, it's like 3x or more
It's
higher.
10 times the last time I checked. Yeah.
Yeah, so again, the question is shortcutting, precision, everything
I
else.
know it's
Yeah, yeah.
everything's very generic and
Right.
oversimplified and
Right. So when we're making the kind of shortcuts I make, it's pretty conservative, and it's actually not as bad as the papers make it
yeah.
seem. But
Mhm.
HEVC, stops at 32 by 32 for transforms. You can do coding units up to 64 by 64, but almost no one in the hardware space, NVIDIA in particular, doesn't go beyond 32 by 32 transform or coding units. Only x265 does. And now x265, of course, only uses 64 by 64 for inter predictions. Intra is still 32. So it's like, what? Okay, now I
Yeah.
can do 64 by 64, and you can do per subblock transforms in VVC. You can't do that in ABC or HEVC. I don't know if per subblock matters much for what I've seen in terms of coding decisions. It'd have to be a real exceptional case, like explicit like synthetic graphics and rendered stuff with real noisy film grain behind it, maybe. Those are really rare corner cases in most broadcast needs. So it's kind of orthogonal there. I mean, comparing one more big thing, and I just brought up my notes that I had hammered out before we were even doing this discussion here. The thing with BBC is that they've got a little bit of an interesting improvement with the adaptive loop filter, not just the in-loop deblocking kind of side data we get with HEVC and AVC, but now there's an explicit way to state how to smooth, how to do this broader deblocking stuff that's not so negative on edges. The big challenge,
Mm.
if you're doing deblocking across CUs or TUs across ranges in the frame, where an edge occurred kind of confounds good deblocking in the presence of like high contrast gradient stuff. And that's again back to synthetic graphics, text, fonts, that kind of thing on top of natural video or on top of synthetic video. So cinema might not care at all. In fact, it's orthogonal in so many ways.
Yeah.
The one thing that I haven't seen though in really HEVC or BBC get used much in broadcast, except for what I've done, is film grain synthesis and synthetic grain layers. Um,
Mm.
that's a major efficiency that I don't emphasize much in the presentations to the point here, but that is what makes things like classic Blade Runner from 1980s on literal positive negative combo stacked celluloid. It's grainy as heck and it looks good if you have a nice high clean crisp copy of it, but it makes these things challenging to encode at low rates because of all the divergent things a codec wants to do to adaptively quantize out and minimize rate. And so if you can separate noise from not noisy things, like less entropically rich things like whole shapes moving around, faces, people, scenery, and take the grain out of that and then put it back in with another synthesis layer, now all of a sudden we kind of get what we want in both ways. We get the large object, large macro features right, and we don't have weird things like mismatched structure of grain and some static grain and moving grain versus luminance features, for example,
Wow.
which you see on a lot of encoding decisions today. Take for example, any dark scene, light scene, high contrast.
Hmm.
Most codecs crush low luma noise before they crush high luma noise. It
Hmm.
makes perfect sense in most cases. But when the scene is, film X or film whatever with high grain, the point is the grain. And so separating that algorithmically is a huge boost in terms of overall efficiency. But neither approach, VVC or HEVC or anything in the encoder space, has really changed any major things there about how that could work.
Well, and I think that would be a good application for like 8K Blu-ray or things of that nature. Maybe I mean films are still being shot with film today.
Right, right.
I guess I should take a step back and realize that. But with so much content now being digital, like just completely digital production, that is kind of a niche thing, but I find it technically like incredible. So it is the same one-to-one grain that you're extracting and then encoding the like regular material and then re-injecting that same grain, or is it a faux grain?
Well, so
Like,
so the approach borrows a lot of what we see in high efficiency advanced audio codec, the HEAAC version 2, where the notion and the buzzword was spectral band replication in that context, where the main codec data would code left plus right like a sum signal as a 0 to 7 kilohertz band limited copy of the audio. And then the 7K to the rest of the channel, whether it's 22K cutoff or 24K, whatever, would be replicated from the spectral footprint, if you will, of the lower 7 kilohertz. Clever, because people realize that much of the high frequency sonic information above 6, 7K was temporally localized to events well below the high frequencies we cared about. So they would already be in time if we could just trigger them to happen right with the transient or whatever the wave was below 7 kilohertz. And all of a sudden, if you just kind of have modulation commands and tuning commands, you can now synthesize this kind of chiffy, chirpy, white noisy, filtered transient enhancement on top of essentially the lower 7K of the passband. Boom, everyone's happy. It sounds like it's pretty good high frequency data to most listeners, and not much was lost. Not much of value was lost. And so it goes. And so if you look at film grain, imagine taking a kind of bottom up, like progressively revealing more and more data. And imagine like a super low passed frame or a super filtered frame, like just averaged out, and progressively less and less filtered. At some point, you'll find a knee where you start to uptick and gain a lot of entropy from all this enhanced, or not enhanced, but all this high frequency grain that's there. And so you pick your knee somewhere and say, okay, things above this frequency domain and band are probably noisy things that are grain structure. Things below this knee are probably real image structure. And so you want to have an adaptive process to find that knee, and then per frame or per sequence of frames or whatever, tell the playback thing, hey, the average grain structure was this chromaticity range, this luminance range, this size, go and make it happen. And now the decoder just inserts that noise that we did not code then in the low pass frame data.
Boy,
So
that is smart. That is a really
exactly. But here's the thing though, people have been doing this in different ways for the dawn of codecs, really. Even back in the 70s and 80s when we had speech codecs being the primary focus of R&D, people realized that I can separate different bands of audio, even in a voice channel, a 4 kilohertz voice channel, and gain something more than
yeah.
I did previously by coding them separately. And if there are interrelated parts of the signal, which speech, a single speaker was, of course, it's an easy thing to exploit. And so now with things like the audio example of SBR, even MP3 Plus had something like that for a fake high frequency reproduction channel. You can now use small numbers of kilobits to inform the decoder how to make and recreate most of the high frequency energy as a harmonically related and temporally related component, or a piece rather, of what was in the lower passband. And so
I
just like that
yeah.
in NVIDIA, we have that now.
I want to touch on that because all this talk about AAC and audio codecs, it reminds me of Google's Lyra. And I want to jump into just now that we're going into codecs, why not? It's fun. Um, AI codecs, right? There's some discussion about, if you think like at a fundamental level, Claude Shannon's theory of, perceiving something real with bits, right? Like if we just take that for a second, just think about that. I'm just curious what your stance is on a potential future AI codec where it is just such little data capacity and it's like, it's a door, but the door handle was actually like silver and the AI puts it as like copper colored. Like
Yeah.
what is your like morally, I mean, obviously there's things with, health records and all
Yeah.
sorts of stuff where they're like governmental security cameras where this is like, you know, major, but
Yeah.
I'd love to have you talk about that.
So we have some good examples. I will send you the link later. There's a page with a bunch of encoded examples of like some I think some punk tracks, some vocal tracks, pop stuff, and they compare the raw wave input to a large transformer model, not a full LLM, but a tuned, contrived transformer
Yeah.
series, where then a decoder, another transformer network with some sort of back propagation magic stuff going on, they can take a context block and prime the decoder to synthesize things from the context with a weak prompt stream as low as 6 to 7 kilobits, and then recreate two PCM audio channels that play back in your ears and sound a lot like the original signal, as low as 6 to 7 kilobits. So the idea here is that we're already looking at large scale features in a large corpus of audio across thousands, millions of inputs, and generating hundreds of millions to billions of parameters that can now be shrunk into a transformer and given to a decoder. But the cost is now the decoder has big memory, gigabytes of memory, right? As you know, in LLMs and everything else. And now the inference steps are, the next token is an amplitude sample. So I want to get 48,000 tokens a second times two. Okay, interesting problem. So as this thing continuously solves through its state space, following whatever paths are set into the model, just to get to the next token, the next audio sample requires this entire traversal of all this memory at once, or as fast as it can happen, to get to the next token, being the next sample to play, given all the previous samples in my prompt. So imagine I'm continuously prompting this thing to guide it through its encoded space, its model space, to recreate the next token, which is my corresponding audio sample for two channels. We're not there yet. It can't run in real time that I'm aware of. We can get like tens of or 30s of or maybe hundreds of tokens a second out of these things, but not 48,000 times two. So I don't see that as being practical at all yet. Maybe in 10 years, 5 years. Or someone develops some massive parallelism, some cheats to accelerate all that. Great, possible. But we got to go from like hundreds to like tens of thousands.
Yeah.
That's a big power gap right now in the inference set. So between that, call it asymptotic modeling thing and traditional codecs, which are kind of paint by spectral numbers, if we were to borrow my earlier metaphor, these transform codecs are giving us sonic data from a very weak stream of bits that convince us we're hearing high frequency transients and snare drums and keyboards or whatever it is. If we look at how those are evolving, they can actually right now be informed better by large language models in terms of tuning and optimization.
Yeah.
We're just, and as you probably have seen, we're just beginning to get into that, where Facebook years ago bought some companies that were doing model-based video encoding prioritization. So adaptive quantizer, all these kinds of things that would prioritize, features that you cared about, human objects, faces, speech, that kind of stuff, versus grass and backgrounds, everything else. That's already been in the kind of in the hopper for the last, say, 10 years now in a popular way. That should start to turn that crank a lot more rapidly, I would think. We should expect to see encoders gain a lot more with the existing syntax than we ever have previously. So I feel like that's a likelihood. The challenge, though, is getting, the future codec work to look anything like that. And I just don't know where that transformer model or LLM kind of angle could condense enough into this practical space.
Yeah. Are you at all worried that it'll get to a point where the data capacity is just too low and we're living in a world where it's close enough, but not, I mean, what we're doing right now isn't perfect, obviously, but this takes it to a whole nother extreme.
Yeah, well, so I think the first thing we're going to get, I mean, the first, if I'm putting my prediction hat on, I think the first thing we're going to get out of all this is an acceleration in huge, delta frame sort of structural rate control things. And so what I mean by that, well, the thing that I mentioned earlier, when we're doing these cinema encodes and these high quality encodes down to small numbers of bits. The dependency is that we have a huge look ahead. We know a lot about the upcoming frames to decide how to encode the current frame. With absent that information, we make shit decisions for this current frame. We waste bits or we undershoot or overshoot, and we have to make up for that over time. Negatives, we want to minimize those. So what can I accelerate in this process? Well, feature extraction, object detection, those can be done really rapidly. I can take a whole frame right now, and even with a 400 by 300 subsample of that, run that through like given any image model out there and get an answer back about what's in it to a large number of features in like 20 or 30 milliseconds on low end, massive matrix multiplication accelerated kinds of CPUs, like little ARM stuff that runs on like 3 watts can do this in like milliseconds. So that seems like an obvious win. Run that stuff.
Oh yeah.
Let's look ahead 20, 30, 300 frames. Who cares? I can
And
do it.
that's AI assisted based on what we're currently doing, but just AI, it's like the human part is taken out and it's now the
Yeah. Right now, Dylan, state of the art, does beautiful real-time object and feature extraction and detection in arbitrarily large frames. It
Mhm.
works great. It's not everywhere, and not everybody has it in their encoder, but an encoder could use that, tomorrow if someone wanted to write that. And that wouldn't change anything about the bit stream that we produce. It would have a better bit stream, ideally, about the things that we're consciously aware of. So in terms of quality, in terms of fooling, and again, the big game in all of this, as I feel, is
Biology. Or
It's fooling my ears and eyes, right? That's
yeah.
that's why this is such a fun place to work and spend time in. Because when I trick myself, it feels like I did something right. And so when I think about what's good at that, what's a good way to do that, I'm always met with a challenge, and that is whenever I shift my attention, whenever I focus on something in the image or the audio that I'm hearing on playback, I can sometimes find things that don't fool me. But again, it's only in the case where I'm really focusing on that. And I think about what that means. We look at the current work that I cited in my last presentation, I forgot IEEE, and that is the recognition that after we filter through 12, 13, 14 megabits of input, smell, sight, sound, taste, touch, everything, we get about 50 bits a second of conscious awareness of state changes in whatever it is we're focusing on. That's not to be underappreciated. That's a critical point, though. And that is to say, what am I focusing on? Well, if I'm listening to an MP3 encoding of a classic jazz record, and I know how the room's supposed to sound and where the drum set was in it spatially, and the rim shots don't sound good, and I hear pre-echo, that's annoying as shit. But I know what to listen for, Dylan. That's the problem. I know what a bad pre-echo sounds like on a transient because I've heard of
I'm
it.
a drummer, so I know.
And
Yeah.
you're a drummer. And I'm a drummer too. Funny, funny,
Oh no,
funny.
really?
Yeah, absolutely. I'll paste some pictures
That's
later.
awesome. Yeah.
Anyway, but the idea though is that that I know how these events sound or could sound, and I know that in encoding stereo with rich phase and frequency specific, arrival information, that all these things are smeared to some degree given the transform. We know that, and then we throw bits away, it gets even worse. So having heard those impressions of those real sounds, now my conscious 50 bits a second of awareness might be distracted by those things. So what can we do? Well, I can try to minimize where those errors happen. I can try to distribute them into different things that maybe aren't as attention deserving or as attention encouraging. So back to models, back to AI. Where can we help ourselves here? Well, if I look at the totality of film and broadcast TV and everything else, and have some data based on maybe some eye tracking or some user interaction kind of things, I can kind of build I think, probably a lot better model of attention, where it's likely to be, where it's not likely to be. And now with the luxury of look ahead and buffer and time, making better decisions should get easier and easier in the encoding side. And then ultimately the transport piece and the delivery piece can use less bits to do the same kind of thing. But again, without that information, without that supplemental layer, I don't know that I'm making any better decisions fundamentally.
Wow. And this is all lossy compression. This isn't lossless because, we're talking about the human eye or the human ear. Um, I'm not sure, there's Kolmogorov's limit for, isn't that for lossless compression? That discusses what can be done with binary there's limits to this.
Yeah, well, so I think what you're getting at is various identities and various systems map into what we call a metric entropy feature of some information.
Hmm.
And what we mean by metric entropy is different from Shannon entropy, and that is to
Yep.
say, not just what is the randomness, what is the measure of surprise, which is, I guess, his word for entropy,
Yep.
is it is the measure of what is each discretized symbol contributing to the receiver as I get it, meaning, not just how many bits and how random they are, but what is the difference relative to the other bits I've already gotten. And so entropy is a category apart from the called metric entropy. And in encoding and in the final layers of bit stream formatting, we run the output of macro block and motion vector calculations into something that looks like a linear, a variable length coder, or a dictionary type encoder, or a Huffman encoder, or in the case of HEVC and VBC, an arithmetic encoder.
Hmm.
So the arithmetic encoding world gets exactly to what you're talking about in terms of the theoretical minimum bits to describe an arbitrary symbology. And the challenge in arithmetic encoding, if you dig into it, is you'll recognize quickly it's got to be floating point in the way that we do it today.
Hmm.
And it's about raising, input symbols to a defined power to generate a combined large integer now, or a floating point number rather, which is mostly zero, and a small number of entropy bits that describe the sum of all these input symbols raised to a given power series. and on and on. And so now by arithmetically arranging input symbols, I now only occupy an output numbering space equal to the total valueness across all the input symbols at the consequence and cost of precision in calculating large powers, and then reversing the process in the decoder. So the
Yeah.
challenge in all of this ultimately is beyond the perceptual layer and everything else. We still have this raw stuff of some sort of linear code or arithmetic code to crash and compress all the bits from all the syntax into what are the fewest bits required for all those unique syntax elements. That is not being addressed by any of this work that I'm aware of because it's considered table stakes.
Yep.
It's been done. We've had context adaptive binary arithmetic forever and it's good enough. Really? I don't believe that. So
Yeah.
I think there's some fun assumptions to challenge in just the raw bitstream coding layer above, the wire, but below the call it the slice and call it the macro block and motion vector layer.
Yeah, I think there's just something in like psychology of knowing like, oh man, it's just doing more tricks on me, versus man, I'm getting this code down and it's like real. It's the same thing as before. It's a one-to-one identical copy. I mean, that's why I've been using JXL or JPEG XL on my website
Yep.
that has a lossless, and I just did an image. It was a tiny image that was already super compressed with regular JPEG, but it lowered it from like 390 kilobytes to 320. And it's a one-to-one copy of the same
Sure.
thing. And
Yep.
just knowing that, like psychologically, it's nice to know that I can cut the data capacity and it's an
Right.
exact, it is perfect, representation. So
The-
that it is nice because we will need obviously more lossy compression, and like you've outlined clearly, there is a lot of give with human eyes and with human ears. But whether or not we want to really focus our efforts on either or equally
Yep.
is to be seen. And I think there's a lot of really cool stuff ahead because with the physical layer, there's a lot less we can do, but with code, we
Yep.
still have a long, long ways away to really get down to like,
Right, and
uh,
it needn't be revolutionary. I mean, maybe it's the one thing for listeners in undergrad programs or graduate programs or postdoc or wherever you are. If you're doing research at all, and even if you're just a hobbyist or enthusiast like me, uh, this is a great place to look at for opportunity
oh
because
yeah,
because just bluntly, I mean, it's not typically a thing that you're greeted with in the market. Like when you go look at job ads and want ads, it's not like, hey, I want to hire someone to trick people's eyes or like fool your ears. That's not how it's represented, right? You have, Fraunhofer, you have Main Concept, you have a handful of people in the world doing this fundamental work, but we're all subjected to it all damn day. So maybe get involved and help us out. That'd be great.
it's just crazy how many people right now, how many millions of people are scrolling on videos through TikTok right now, and they have no idea the technology behind what they're looking at.
I mean,
It's
and so informing a future vision of what could be possible does depend on, I think, a little bit of appreciation for where it came from. And part of my journey here was looking at the original work that AT&T did in the 70s, looking at large image corpuses, large being thousands of pictures back then, which were hard to store on low density hard drives and so forth. And
mm,
imagine teasing out some decent principles and principles and approaches to discrete cosine transforms. How big should it be? 16, 8, 4, pixel by pixel? Who knew? Let's check it out. Let's see what happens. And on and on. And here we are doing almost identical work to that very first line of inquiry into transforming information into things that we could allowably reduce. But then at the same time, again, back to channel capacity, physical layer, we've gone from kilobits on line speeds to I have a gigabit in my house that
yeah.
could be 10 gigabits if I paid AT&T a few more dollars. I mean, this is gratuitous, but what are we going to do with it? 8K VR immersive? I don't know. But I digress. So I guess the point is to say that there is just a never-ending interest, I think, in this pastime of sensory, kind of foolery. And I would absolutely encourage anyone in the space or near it to really drive in deep and see if they're inspired.
Oh yeah, and I just think as humans, we're always looking to make things as efficient as possible and to just find, go to the limits and just try to, keep pushing forward. And I think that's a great, motto to have or a great mindset to have.
And along
But
similar lines, I mean, we could look at some work that went into the free lossless audio codec, FLAC, as
yep,
a good example of an unexpected, totally unexpected and unanticipated way to get almost 2-to-1 reduction on any PCM system
yep,
at all.
or like
And
AIFF and stuff like that,
yeah, I mean, in different degrees.
or
I mean, but look, if you
PCM.
look, right, well, so PCM might have been our initial idea of representing, this large scalar quantizer space as just a code. But the idea is that all codes aren't as valuable to the decoder's state, right? And
Yeah,
so looking at how FLAC does its work, it recognizes that the MSBs and the sign bit and the LSBs are all different statistically in what signals are, right? And previously we had done frequency transforms, complicated multi filter bank kind of things like MPEG one, layer one or two or three, all have different ways to do frequency domain decompositions to give us some sort of gain in coding and reduce things that we don't think are hearable to a listener. Whether they're right or wrong, it's just what it was, right? But then imagine taking a completely different numeric approach, completely differently addressing what is a sample fundamentally in terms of a continuous time signal, and then all of a sudden getting 2-to-1 out of it without changing any of the input data, without throwing anything away fundamentally. Radical difference in terms of the outcomes. And you look at the differences in time. MPEG 1 was around the early 90s, right? MPEG layer 3, MPEG 1 layer 3 came out in the mid 90s. FLAC was much, much later, 20 years later.
yeah,
Nobody would have imagined this. Who would predict that we would go away from all these transform, all these filtered bank codecs and these synthesis codecs to a numeric dictionary codec? Again, like
yeah.
for whatever reason, no one would predict that. But all of a sudden it happens. Someone was inspired. Someone says it should be lossless. Why can't it have some gain? And that's the question you start with. And you end up with math that looks like FLAC. What else could we do? I can't even imagine.
So for, terrestrial networks for, everything from, cell sites to, wireline networks like fiber and such, there's a lot of, theoretical limits in terms of just the overall, structure of how these things are set up. And just to kind of conclude, what's your, overall message or thoughts with the potential that a wireless one-to-many model could provide versus, those?
Yeah. So, I mean, I still, despite all the things that I like about two-way networks and having worked on the internet for so long and have it, supported me for so long in my career, I still can't get away from the idea that 10 million people or 18 million people can't just still today all get the same thing at once reliably on any density deployment I'm aware of anywhere in the world. And so, as much as we don't have, easy access to it, broadcast still is the only thing I can imagine doing this for a while. So, although they're encouraging and selling people gear that comes with built-in antennas, or maybe just sending them antennas, or doing something to make this happen, maybe it's going to be, UE style broadcast reception, whatever those hacks might be. I think we do need to think about how to actually go that direction and have an alternative, at least maybe a plan B that isn't separately owned private terrestrial two-way data networks. The airwaves are regulated how they are regulated. We're still thinking of it as a public thing. It's held in the trust of the government and us as in our society. So I believe that this is still a bit more open and available than some of the things that are privately owned on the internet side. Not everyone can run their own ISP. Certainly not everyone can run their own broadcast facility, but we still have a bit more diversity actually in most markets of broadcast services than we have on two-way data networks. People love to harp on the duopolies everywhere. You might get a cable company in some locations and a telco that was the incumbent or whatever, but you'll have 3 or 4 or 5 or more independent broadcasters in most markets. That is a lot of diversity. That's a lot of competitive opportunity. Can we get that together? Can we find a critical mass that can use that resource and marry up the content? I think the answer is yes, but to our earlier points here, the demands are many and the time is short. So who's going to get working
Yeah.
on that, Dylan?
Yeah. It's, for me, the biggest thing is just how cheap it is for broadcast. I mean, and if you're going, taking a step back, the technical arguments, just thinking of just the population, there
Yep.
are millions of people that live below the poverty line. There are millions of people that can't afford internet service. And My argument would be maybe we shouldn't necessarily subsidize internet, but maybe we should look into just the cheaper alternatives to deliver an internet-like experience to people, especially since the upfront costs are so cheap. And could we make it meaningful for people, using maybe a lot less of a unicast connection and really trying to deploy that wireless multicast connection for these groups, in society. And I think there's a lot, to that. And also what you were saying with the public airwaves, that is huge. And, there's so many people in this country that don't even know what the public airwaves are, why they exist, why it's a resource that we all collectively technically share and stuff like that. And, the internet is very complicated. It's a complicated network of things. The broadcast chain is complicated, but, as soon as it leaves that antenna that's on top of the tower, it's super simple. And I
Yep.
think that simplicity drives costs down. That simplicity and the amount of, just extremely little power consumption just makes everything from accessibility to just overall, corporate, bean counters looking for ways to save money on just services and things like that. It makes it attractive.
Absolutely. I mean, you can't beat the numbers. I mean, if you look at what I've got going on with Channel 3, the call it optimistic estimate is that there's over 400,000 people covered in the antenna radiation pattern contour, given my power level, that can be reached by a single, station. That's tremendous gain. And I can tell you that at my current configuration, to reach that 400,000 population area, plus actually it's well over 400,000, is only about 7 amps at 240 volts. That's like under 1,500 watts. Okay. That's nothing power. That's invisible amounts of power to get data, 19 plus megabits to this large population. Terrestrial networks need power everywhere. Every hop of the way is an active component. So from a pure thermodynamics point of view, this has to be a thing we consider.
Oh yeah.
To our earlier conversation and broader market and economic points, it's all about shiny, follow that ball. Where's the market going? Where's the consumer interest going? Where's it headed? And we want to guess at that as much as we can, and it drives the system forward one further step. If we want to influence that and change it, we got to really think about this structurally and say, what could get us back to this? What could drive things away from that? What would be a big, perhaps a culmination of things that could reignite this sort of interest. And we've tried in different ways, excuse me, we've tried in different ways as different broadcasters to do this, but I don't think anyone's looked at it from that perspective in that way. I think that we could do that, and I think it would show the merits that we're talking about here. For example, something like an HD home run or a
Yeah.
single set-top box vendor could launch, a Zapper box could launch a thing that does some sort of interesting program development with any of these broadcasters we're talking about here. But again, it's a two-party thing. Maybe some content has to come in, three-party thing. So uh, challenging, but certainly tells us where the attention would need to be to achieve that.
Thank you
Pleasure,
so much for coming on. Let's do this again sometime. If there's a
man.
2028 ATSC 3.0 deadline or something, I'd love to have you back on to share some thoughts and stuff like that. And any future video coding or audio coding stuff as well. So it's been a blast. Thank you so much.
You're welcome, Dylan. Pleasure. Have a good day.
Thanks.